So we are wrapping up week 6 today, which means 5 weeks left after this. It's an 11-week term in fall, so well beyond the halfway point, which is surprising, but also good. So go ahead and send me an attendance note, and let's start off with questions. So about a quarter of the class is taking an extension on PA3, so I'm guessing there's still some questions out there. So let's start with questions on PA3 or anything else. Or it may be that people know what to do and just need more time to do it.
I ended up just getting wrapped up in other commitments for a little bit.
Okay, fair enough.
Not really a question, but a comment. I wish I was a Git wizard so I could help a couple of people who, unfortunately, are a little lost in being able to push and pull.
Right. Yeah. And I still don't know what the most common case is that people are running into when they try to push and it says there's a conflict. The only times I've known that to happen is when you're pushing from multiple places or in some way, doing something that changes what you have locally versus what's on GitLab. But there seems to be some other use case because occasionally students are running into that, even though they're only using Git from one machine to GitLab.
It's funny. I actually just had this problem where I couldn't push. It kept rejecting it, saying that my local directory was not the same as that one. And I can't remember exactly what I did, but I had to pull from GitLab so that everything matched, and then I was able to push.
Right. And that's the usual solution, is to pull first. You just want to make sure you back up your stuff on your local machine before you do that, because pulling will potentially change things. Oh yeah. The odd thing with that.
It's just the beginning, but
okay.
I just finished modifying my stick code to match this one with R3 and all that. And I was excited, so I was like, I got it to work. And then I had the issue and lost it completely.
Okay,
I was upset.
Yeah, definitely. Okay, so someone just pointed out one thing that can happen if you push from two different directories. Like if you change directories somewhere along the way and start a new directory and push from there, and then go back to the old one, right? That can make things out of sync. It looks to GitLab as if there's two different things being pushed. The basic problem is you make files A, B, and C, and you push them to GitLab. So now GitLab has files A, B, and C. And then if there were multiple users, so this other machine would pull A, B, C, and then it would make a new version, C2, and push that up, and so this changes to C2. And so if I make some changes to C to C3 and I try to push, GitLab's going to say, hey, you're trying to change file C into file C3. I don't have file C anymore. I've got a file C2. And it's going to say, there's a conflict. And what you would like to do is, before you make this change, you'd like to do a pull. This will change to C2. And then when you change it to C3 and you say push, GitLab will say, oh, you just changed C2 to C3. Okay, no problem. I'll just change that. But yeah, I think the same thing can happen if you switch directories at some point, then it looks the same. You're doing things from over here, and it looks...
So would you say, like, if you're using two different computers, your best bet would be pull before you start doing anything?
Always pull before you push. There's even a haiku that says that. and if you do that consistently, it should work out. Now, once in a while, I swear, you know, I pull before I push, and I still get an error, and I can hear like laughter coming from GitLab town. Um, and I'm positive, you know, I did everything the way I was supposed to, and it still just like happens once in a while. So I don't know, but yeah,
The funny thing is, yeah, I've never had, or I never used another computer to push into it, so I don't know what the problem was or why it was giving me an issue. But
different directories maybe.
no, the only thing that was different was I created PA3 on my computer, and I hadn't pushed it to GitLab yet. And so when I went to push it, it wouldn't allow me to. It said there was some changes on GitLab that weren't on my local directories. So I thought that was weird. And I tried, I mean, it took me about 45 minutes because it wouldn't just let me pull. I had to
Right.
go on some forums and figure it out. Ultimately got it, but
Right. And you're only doing it from your local machine, not from the Linux server?
no, I'm doing it from the Linux server only.
Oh, okay, okay.
I'm not doing it all on my local machine.
Okay. Yeah, so I don't know what the exact use case is that's causing that. Absolute worst case, right? You can always, you know, make sure you have your work on your machine, either the Linux server or your laptop, whatever you're working from. You can always log on to GitLab. You can delete the repository on GitLab, and then just do another git push from Linux, and it should create that directory for you, and then just go in and set the permissions so that I have access to it as a reporter. That's kind of sloppy, but you know, it works perfectly as long as your local version is intact. But
Yeah, that was one thing I was like, I just wanted to make sure, obviously, that there was no chance of losing both of them. You know?
right,
So,
and
like I said, I got it sorted out. So
cool. If we're done and comfortable with PA3, is there anything we should stick around for? After PA3 questions, I'm going to start talking more about Linux. I'm going to talk about files, directories, moving and renaming, doing those with Git, ownerships, and working up to talking about inodes and symbolic links. So, but if we have questions that take the entire period on PA3, we'll spend the entire period. So it kind of depends how it goes. Let's see. Let me make some notes. Having issues pushing from within the PA3 subfolder because of permission. That's a little unusual. So make sure that you're never doing git init, right? And you're never doing git remote add origin. You did that in the beginning of the course. Don't do that from a subdirectory. If you do, then that will cause conflicts and maybe permission issues. Naming a directory and program the same should not get you into trouble, but it's possible. Yeah, we make mistakes to learn, right? That's the only way we really learn. I mean, we can read things and we can study things and memorize things, but you know, it's in the process of making mistakes and working through that we learn. This is one of my favorite things I saw once from Chegg. It says, don't waste time struggling with homework. Get Chegg study. Because why would you want to apply effort while doing homework, right? Don't you want to just like get it done and get on with your life? Because that's why homework is assigned to you. It's just a punishment to keep people busy. You know, the struggle is where the learning happens, right? Whether it's doing physics problems or debugging code or anything like that. So yeah, I stumbled across that today. Nothing more humbling than crying at odd times of night into a pile of old forum posts. That's poetic. That could be like, you know, in a Dylan song or something. Or staring at a Git status. Git, I will freely admit, Git can be very, very frustrating. And like I say, you know, when it's not 11th hour, practice just like getting rid of your repository on GitLab and starting over, right? Make yourself, make sure you have this final option to just kind of rebuild the repo from scratch on GitLab, because it's always an option. And sometimes things just get so tangled out, and it's just really hard to sort that out. Nothing to commit, your directory is clean. Yeah, that's usually okay. You get random file types on your GitLab. If you have an a.out, it may be did a GCC without the -o option, and that generates an executable called a.out. And the fun thing about that is you just made some change to your program, you did GCC, but you forgot the -o, and you run your program and your change doesn't seem to have worked because it didn't actually recompile it into the path you thought. A little tip for those who are interested: if you're running Linux subsystem for Windows, you can run WinSCP alongside your kernel if you want to bring up old programs for reference. That's cool, yeah.
So I recalled you recommending not using WSL a while back. I believe you said it was something about like the way that Windows handles like new lines and end of character line, or no, or just like end of string characters or something.
So those should be okay with WSL. It should be using new lines for end of lines and so on. So one definite issue is being able to do graphic output. So it may be that you know, things you can do on your own Linux system that create GUIs, for example, doesn't necessarily work under WSL unless you also run an X server. They may have fixed that by now, I'm not sure. But there was one case where, I don't remember the details, but a few weeks ago somebody was trying to do something, I think with Git, and the Windows side seemed to be getting confused on uppercase, lowercase, and they had tried to like change a file and it wasn't recognizing it. I don't remember exactly. I mean, it should work basically, you know, as Linux, but every now and then either myself or somebody else stumbles across something where it's like, yeah, that doesn't work yet, you know, and there's usually a workaround, but it's you know, another variable that you can avoid if you just sort of use VirtualBox and install Ubuntu yourself. That's all. But some people swear by it, which is good. I do know that if you run WSL, that seems to hamstring VirtualBox. And to get VirtualBox to run, I had to turn off some version of hyperthreading or something that would break WSL. But VirtualBox wasn't working correctly. Let's see, physics. Oh yeah, physics, good. Sleepy delirium, panic, yeah. Cool, alright, so some people are having good success with WSL, so that's good. Alright, cool. So other questions? Alright, so let's do some more Linux stuff. Let's misspell the word more. Oh yeah, Hyper-V software. Let's see. So we've talked about a bunch of things about Linux, but a lot of this we've sort of been picking up kind of along the way of doing other things. So I wanna make a few specific observations or comments on Linux. So the first thing is this idea that everything in Linux is basically a file, right? So we know that the files we create are files, but directories are also files. So what's a file? It's an area on your disk that contains binary information, and somewhere there's something that points to that area and says, hey, this stuff is the file called set prompt or whatever. And directories are just another file. They have a particular structure, and what directories do is they contain the information that you need to be able to find other files on your hard drive. And so if I do my ls-l, sometimes my files begin with a dash in column 1. That means it's a plain old file. I can edit it and so on. Sometimes my lines begin with a D in column 1. That means that's a folder or a directory. And so if I look inside one of these folders, like public HTML, there's other files in there. And there could be other directories in there, and so on. So, OL is a directory inside there, and so on. So we know about this hierarchy of files starting with /. There's a directory home, there's a subdirectory nic, there's a subdirectory public HTML, there's a subdirectory OL, and so on. But there's other things that are files also. So if we go into the /dev for device directory and we do an ls-l, these are in some form or another physical devices that correspond to hardware on the system. So for example, disk, right, is related to well, disk is a directory. Let's not use that one. FD, well, we'll talk about links in a bit. I2C-0, right? So there's a way that I can do communication with physical devices connected to this machine using something called IIC, communication, I2C. And I get to that interface through this file, I2C-0. So SDA is a thank you for that. SDA is a file that corresponds to my hard drive, one of my hard drives. And this B in the beginning, column 1, says this is a binary file. I access it as a binary device, whereas TTY, for example, has a C in column 1. That's a device that I access as a character device. And the difference is sort of how cooked the device is. So my TTY, that's my screen and my keyboard, right? I can write into this device, and whatever I write into here will appear on my window. And if I read from this device, it will read whatever I type. And so the fact that these are files means that if I know how to open up a file and read from it or write to it, I can open up, my TTY or my hard drive or my network or any other piece of hardware on the system, and I can interact with it by doing the same things I do when I want to read from my keyboard or write to my screen. I can do fopen, I can do fgets, I can do fprintf, I can do fclose. And by doing those on these files, I can interact with the hardware. I can interact with the network controller. I can interact with the printer, and so on. And so TTY is my terminal. And if I do something like, say cat greater than /dev/TTY, whatever I type appears, it gets sent to this file, and this file is my display. and so I see it on my output. If I cat/dev/tty, cat is trying to read the contents of this file. Well, what's the contents of this file? It's whatever I type and hit enter, and so it's echoing what I type. But if this was, you know, an old school Linux system and somebody was logged in on TTY1, which would be a different physical keyboard and display, I could cat something into TTY1 and it would show up on their display. And if I tried to read this, I would read what they were typing. Right? So these are just plain old files, but they're actually files that interact with hardware typically. And random, I think, is a random number generator. I'm kind of guessing that. Mem is, or was at one time, the actual memory. So you could treat your whole memory of your computer as just one big long file and open it up and so on and so forth. So yeah, sudo tells you to be responsible because these things are files. Files, we control access to files with these permission bits. And the permission bits, remember, there's three groups. These 3 bits say what the owner can do. These say what the group can do. These say what everybody else in the world can do. And most of these files are owned by root. And root has read and write access to most of these files. So when you say sudo, you're telling the system, treat me as if my user ID was root. Which means once you say sudo, you have read-write access to all the hardware on the system. And if you can access all the hardware and you can access all the files, you can do anything you want to anything on the system. So sudo usually says, you know, with great power comes great responsibility or something like that. I don't know what 0 is. Oh, 0 is another null device. All right, so yeah, there's a special device called null, and that's the bit bucket. So anything that you write into null disappears. Anytime you try to read from null, you read nothing. So if I cat/dev/null, it just comes back right away. It hits the end of the file without typing anything. If I try to redirect into dev null, right, those things that I typed into dev null just disappear. And if I look at dev null, it's still empty. So it's kind of like a black hole, right? You can't read anything out of it, you can't write anything, and you can write things into it, but they just disappear. And that's a surprisingly useful device. So for example, if you're running a command and it's going to generate some warnings, but you don't really care about it, you don't want to see those warnings, I could run my command and I could redirect the output to dev null. And then all the chattiness that it makes, I wouldn't see. It would just basically disappear. If you plug in a USB device, let me see if I don't think I have a USB handy. If you plug in a USB device, you'll see a new thing here, usually called TTY USB 0 or something like that. It depends on the system. And that's, you know, just a file. You can open it up, and if you do an fprintf into it, whatever you printf will be sent to that USB device to do with whatever it chooses to do. And if that device is generating information, like if it's a GPS dongle, and I were to, you know, cat that device, or open it up and read from it, I would read the messages that were being sent by this GPS dongle. So it's a unified way of interacting with files and devices, and because all of our file access is controlled with these permission bits, these are really the key to basically locking down and securing a Unix system. Yeah, that did seem like a kind of harsh way to deal with warnings. Now, if I say df, df is a command for looking at my disks on my storage on my system. And for example, slash is my root directory, and that's my really fast solid state drive. I think it's an NMI drive. And over here, slash dev slash nvme blah blah blah, right? That's a device, and it's under slash dev. It's a binary special file, and it's owned by root. The group owners is a group called disk. That's the interface to that piece of physical hardware that contains on top of it, you know, information about file systems and information about directories inside that file system and the actual files themselves. Slash HDD is a larger but slower solid state drive, just a plain old SSD, that I use for bigger storage, and that's associated with this physical device, which is dev SDA. That's the one we looked at a minute ago. That's also a binary special file, right? And same permission and ownership and so on. And then slash media slash NIC slash external backup, that's an external drive that I have. And the file on that starts with 2 slashes. This is actually a networked device. So it's sitting on a different machine with that IP address. And this is set up through Samba, so it's just another way to do networking. But it still basically acts like just a plain old file. Yeah, I think that's what it is, NVMe MEs. And this laptop came with one, and it was like shockingly fast, because I'd used SSDs and I was like, yeah, it's faster, but it's not mind-blowing, and this thing is like totally mind-blowing. It's like I boot in like 5 seconds or something. Cool. All right, so files, right? Basically, that's what everything on the system is. And so the things that we learn to do with files, right, we can use to interact with all sorts of different aspects of a Linux system. So for example, I have this file called in.c, and I can look at it by saying cat, and cat, you know, displays the contents of a file. I could also look at it by doing more, and if the file is very large, let's do this. Let's make a big file. So if I cat a big file, it just, you know, flies off the end of the screen, and I can go back and look at the parts that disappeared. But if I want to look at a file one page at a time, I can use the more command, and it'll show me, you know, one screen full at a time. I can hit the space bar to go on to the next. I can hit a question mark for help on what I can do in here, and it says, you know, space displays the next screen size, but you can search for things and so on and so forth. And I can also hit a Q to quit. So we can use cat. We can use more. There's also a command less that some people like. What I probably don't want to do is use VI though to look at a file. Unless I'm planning to edit it, I would stay away from VI, because it's too easy if you're in VI to accidentally type something and end up changing your file. And if you habitually exit your file with, you know, by writing it out, you can, you know, munge your file without meaning to. So yeah, you can look at your file inside VI, but more is probably the more usual way to do it. And if you're in more and you decide you really do want to edit your file at this point, you can just hit a V, and it'll pop you into VI. It's like Diet Oreos. Okay, I'm behind on the chat, I guess. All right, so couple of options, right? So if you want to rename a file, if I want to change in.c to, input.c, I can say move in.c, input.c. So move old name, new name. That's the rename command. And if I want to copy a file, I can copy input.c to new input.c. And now, my in.c got renamed to input, but I made a copy of it named new input.c. And the difference between copying and moving is move is just a rename, right? So input.c is listed as being created October 26th, right? That was the date in which the original file in.c was created. But if I copy input.c to new input, that's creating a new file, and that was created today at 11:30. So copy and move both create the source file, but one of them just renames the old, the other makes a copy of it. And then to remove a file, we can use rm. So I can remove new input.c, and it deletes it. Now the funny thing is, if I'm working in Git, so I've got all these files and they're under Git control. If I move in, I rename in to new in was just in, and I do a git status, it's going to say, hey, this file disappeared, and this file isn't being tracked. And so I can, add those. And it still, realizes that this file has been deleted. It doesn't understand why, right? And the problem is, Git is trying to manage your files for you. And if I just pop in there from the command line and I delete a file or I rename a file, Git's left wondering, hey, where's this file? This thing that was called in. What happened to it? So the proper way to do that is to use git move or git remove delete, and so now it knows that git has been deleted, and it's waiting for me to commit that. And if I do that, then everything will be clean. So now if I want to rename a file like big, I could say git move big, new big, and everything is clean. It knows that this file was renamed. It's waiting for me to commit that change, so I can just say git commit. And now if I do a git status, everything's clean. So git mv to rename a file and git rm to remove a file. And then you're keeping Git clued in on what it is that you're doing. All right. Removing stuff. So here's my make stuff directory. And inside here I have a backup directory, and inside my backup directory I have some subdirectories. And inside those I have some other files and so on and so forth. So, I have this whole directory tree now sitting underneath my CSE224. I've got make stuff, I've got backup, I've got this directory, and so on. And if I want to get rid of some of these, it can be a little tricky. So let's say I just want to get rid of everything under make stuff, right? If I do remove make stuff, it'll yell at me and say I can't do that. That's a directory. So I can try remove directory, but it will not do that if I have other things underneath there. So I would have to go into make stuff, and I'd have to say, let's get rid of everything that's in here. But I can't do that because there's a backup directory. And if I try to remove the backup directory, it's going to say that's not empty. Right? So it's hard using just remove and remove dir to clear out a whole subtree. But we can put a switch on remove. We can say remove recursively. We can do a -r. And if I say rm-r make stuff, that will go through and delete this file, and if it's a directory, delete all the files and directories in that directory. So this will recursively go through. Let me do an ls right here. So if I do rm-r make stuff, that gets rid of the whole directory tree and now make stuff, and everything that was underneath it is gone. And I guess the point of rm-dir is maybe if you don't want to just kind of blow everything away, if you want to be very sort of tactical in how you're removing things, you would remove a directory only if it was empty, right? So like I do this under Windows. If I'm trying to delete a folder, I'll click into it and make sure it's empty first, because you know, a lot of my folders have the same names, they're just in different positions. And so I want to make sure this thing's empty before I delete it. Well, rm-dir basically lets you do that. But, you know, you could also put switches on rm to make it interactive. And so, yeah, someone mentioned in chat rm-rf. So the r makes it recursive, the f forces it to delete. So if, for example, if I try to delete everything in here, it'll tell me, hey, go-to is a write-protected file. Do you really want to delete it? So go-to, I don't have permission to delete normally. But since it knows that, you know, I own it and I could change the permission, it will ask me, do you want to go ahead and delete it? So I could also just do an rm-f for force, and that will not bother asking me for confirmation. And so if I want to delete my entire 224 directory, I can do rm-rf CSE224, and that wipes out the whole thing. Hopefully I didn't have anything good in there. Alright, so yeah, rm-dir might be useful in a script. I think it's a more subtle way of deleting a directory. Let me see what it says. Remove the directories if they are empty. Oh, and it's a wrapper around the system level. Remove dir. All right, so files. So permission bits, right? So every file has associated with it an owner and a group. So this file new is owned by Nick, and the group that owns it is also called Nick. That's my default group. And groups are just a coarser way of identifying users. So each person who has a login on a system has their own user ID. But you could have multiple people who belong to the same group. And if you were working with, you know, 3 friends on a project, you might put the 4 of you into a group, and then you could control access to this file through that group ID. And you might say, okay, nobody in the world has any access to this file, but anybody in the group can read and write the file. And now if one person creates that file, somebody else can go in and edit it, somebody else could go in and edit it some more, and so on. And if you're all in the same group, and that group you know, is the group that owns the file, then you can basically share file access like that. and you can belong to multiple groups. So like I happen to be in a bunch of groups. I have no idea what most of these are. But if I wanted to change this file to be owned by the group, I don't know, dip, I could say change group dip new, and now when I look at this file, the group is dip. So the owner, Nick, has read-write access, but anybody who belongs to this group now has read-write access to this file. And anybody who is not Nick and does not belong to the group dip has read-only access to this file. That's the world. So it's a little bit of flexibility in how you control access to files. And this also works for directories. So you can collaborate on one machine with other people by setting up those permission bits.
When you're setting permission bits, like if you like chmod 755, that's one way to do it. Can you just go through and type out like -rw?
No, but you can do. I never remember these exactly, but I'll take a shot at it. You can do change mod owner plus execute. Oh, other. Okay. So this said the others, right, which is the world. I want to add execute permission, and so that turned on this bit. If I said change mod user plus execute, that set the execute bit for the user. And if I said group minus write new, that takes away the write permission.
Like want to change one of the permission bits.
Yeah, that's very useful, and if you use it often enough to remember that it's owner, user, or user group and other, then yeah, that's quicker than doing the octal. But anytime you can write octal code on a screen, it's always like bonus points, because people watching you from a cafe will be impressed or scared.
The only cafe I can think of is Starbucks, and I think they'd all be scared.
Well, that's worthwhile. Someday I may tell you a funny anecdote related to that, where I impressed somebody on an airplane with my typing, and then like really impressed them later on for a different reason. All right, so we can change the ownership and the group ownership. We can change the owner, right? I could say, let's make this file so that it's owned by root, but you need permissions to do that. And root, I think, is the only person who can actually change permissions, because you'd need to have permission as both the old user and the new one. Yeah, that's cool when people are impressed with your typing speed. Yeah, and you can always do hacker type, and just bang on your keys and get all kinds of good stuff like this.
They caught me. Alright, hold on. Gotta turn on incognito mode.
Yeah, exactly. Let's see. Alright, so ownerships and groups. Alright, so any questions about any of that? Oh, you're in. Excellent. So let's talk about inodes. And this is a bit of a big gear change to start on a Friday, but we can start it anyway. So I've got this file named new. These are the permission bits. So there's 9 bits for controlling access. This first field, this dash, is a dash for a regular file, D for a directory, B or C for I/O devices, and there's other things that this can have. Someone asked what this is in the previous class, and I'm not sure, but I think it's related to something about the contents of that if it's a directory. This is the owner, this is the group, this is a timestamp, which I believe is modification or creation time, and then the file name. And there's nothing magic about those, right? These are just the default fields that LS shows you, but you can ask LS to give you all of this information, right? We could ask for example, we could ask for the group or to suppress the group name. We can ask for the full time instead of just an abbreviated timestamp. So we can use ls to display whatever information we want, but just plain old ls-l displays certain fields. So -I is a really useful switch to play with. It says print the index number of each file. And if we do ls-I, I get this weird number next to new. Are we going to have any group work here in the near future? I'm thinking PA4 will be a group project. I haven't dug into it yet, but I would like to have one group project in this class. It's going to be 4 or 5, but I gotta work that out in the next week. So yeah, there will be a group project. And it will be an option to, work in groups of up to 3 people probably, or to work alone. Yeah, solve TS, that would be good. All right, so ls-I shows me this number next to new. This is what's called an inode number, and it's a unique number per file. So if I go into my home directory and I just do ls-I, right, each of my files has a different number next to it. This is, you can think of it kind of as like an entry into an array. It's an index. It's something that uniquely corresponds to this file. And if I go into the root directory and I do an ls-I, I've got some smaller numbers. And here's a file called proc, and that's file ID 1. And here's dev, which is file ID 2, and core is 15, and HDD is 2, and backup is 16. So how do files get organized in an operating system? Something somewhere has to have a way of saying, when you say cat main.c, you're asking it to show you the contents of some part of your hard drive. So how does cat main.c turn into showing you the source code from your file? Well, your code is stored on a physical hard drive, and it's stored in different locations, and it may not all be in one location. It may be broken up in different spots on your drive, but something somewhere is keeping track of that, right? So there's data structures, things we'll talk about in 222, that identify where on the hard drive the different parts of your file are. But when you say cat main.c, the way that those data structures are found begins with this inode number. And so I might want to do something with init-rd.img, but really quickly what I'm going to be trying to do is working with file 95. And this 95 can be used to go through a data structure and find the information about this file that tells me, among other things, where it's stored on the physical hard drive. So every file has a number, and these numbers are unique for unique files.
So that's like an identifier for the data structure that sorts through where your files are?
Mm-hmm, exactly. So if I copy new to new2, I have another file, new2, with a totally different inode number. But if I say rename new2 to new12 haha, right, new12 haha has the same inode number that new2 had. Or sorry, I renamed new. So new and new12 haha have the same inode number. Yeah, this does impose a limit on the number of files, but that's actually more a function of the file system. So if you're using, you know, FAT or ext2 for Linux, or, you know, NTFS or whatever, that also imposes a limit on the number of files. But I think this is a 32-bit number. I'm not positive. So yeah, that would put a limit on it too. All right, send me a attendance note on the way out. And Monday, I want to dig into inodes, take a little bit more look at this, and use this to start looking at symbolic links. And then I want to talk about a few more utilities: tar, zip, find. And then we're going to start looking deeper at strings in C, and dig into some stuff. And then we'll also talk about doing some GUIs on Linux for probably our next programming assignment. All right, have a good one. I will see you next time.
Thank you.